what the question says is we are given an integer array nums and we need to return the smallest positive integer that is not present in nums, and we must implement an algorithm that runs in O of n time and uses O of 1 auxiliary space. Okay, so just like the one you have solved for the first problem, similar approach is to be used, which is hash set approach. So in this hash set, we'll we'll be going to stuff all the elements in the nums array into it, and then we'll take a number and then check if the current number is present already present in the hash set or not. For example, we have an array, let's say 3, 4, 7 and 10. Okay, so it's obvious that 1 is the answer. But in algorithm, let's say we have this as an array 3, 4, 7 and 10, and we'll have an hash set, and we'll stuff all the elements of array into this hash set, which is 3, 4, 7 and 10 and so on. These are empty boxes. Okay, and now we'll take a number, or sorry, we'll take a variable which keeps record of what current number is. We will initialize this number with 1, and then if this number is in the hash set, we will increment this. Okay, and if not, we'll return this number. So that is, uh, since 1 is not present in it, we'll just return k. But if it is present, let's say if it contains 1, 2 and then let's say 4 and then 6 and so on, for this we'll still initialize this k with 1, and we'll check in the hash set whether this number is present or not. Well, it is present, so we'll increment it and make it to 2, and we'll check again. This is present, so we'll increment this again, and now we'll check in the hash set. This is not present, so we will return this number as the answer. So the code is hash set let's take the variable name as hs and new hash set. And then we'll put all the elements of nums array into this hash set, which is for loop int I is equal to 0, I is less than nums dot length I plus plus, and then hs dot add nums of I. Okay, and then we'll take a variable k and initialize it to 1. Here we also have numbers which are negative. These negative numbers are to be skipped. We don't care about the negative numbers because the question is missing positive, and if there are negatives we will not do anything, we'll just skip it. So for loop, sorry, okay, the idea was if the number, if k is present, then we'll increment it. If not, we'll just return it. So we are going to run a while loop which will check the condition hs.contain contains uh, k. Okay, and this will check whether it is present or not, and if it is present, then we'll just increment k and then check again, and increment, if it is present again, we'll just increment it and check again, and if it is not, it will just abruptly end. The while is the while loop will all automatically end, and then we'll return k. Let's just check. Although this runs in O of n time, there is one thing that we missed. Well, we have not considered this constraint. We have to use O of one auxiliary space. When we use a hash set, we are uh, using an auxiliary space. We are storing these elements in a place, right? So we have created a new space for it. So this is of uh, space complexity of O of n. So we don't want that. Now we are going to use another approach. This approach is called cyclic sort approach. Now in this, what we are going to do is, let's say we have an array of uh, numbers, let's say, okay, sorry, this becomes too simple. Let's say 2, 3, 1, 5, and 7. Okay, so in this array, in this approach, we have an array of 2, 3, 1, 5, and 7 elements. And in this approach, we will be placing the current element in an index which is less than one of it. Okay, and then we will scan the array and check which of the number is out of its place. See, let's say we have an variable I which tracks the indexes of the array. Let it be initialized to 0 because the starting array is 0. Now what we are going to do is, we'll just scan the array once, but also we will be placing the current element, which is nums of I, in an index which is less than one of it. So nums of I minus 1. This is the index and this is the element. We are going to place this element into this index. Okay, so this is the approach. And then after we have done this for every element, we will scan again, we'll scan the array again, and we'll check what number is out of its place. Okay, so the edge cases or the things we have to keep in mind are, if there is an element which is greater than the array size. Let's say we have an element, we have an array of 1, 2, 3, and 27. Well, if you reduce this element by 1, you will get 26, and you will be placing that in an index of 26, right? But the size of the array is just 4. You don't have a size, an index 26. So what we'll be doing is just return this index, which is 4, and this will be our answer. Why? Because there is no number at 4, and the array ended. So we'll just return the 4. And another thing we have to keep in mind, this is the case 1. This is case 1, which is if uh, nums of I, or the last the maximum element, okay, max element, okay, this is the max element. If this is greater than array size, then we'll just return the length of the array. Okay, we'll just return the length of the array. Then the second case is that, what if after placing the elements, which is placed by swapping, okay, we'll swap elements, and that will be placed, okay. What if the element has already been swapped and it's already in place? What if what if that was the case? The answer is, we don't swap it, we just skip it, okay. We'll just check whether it is in place or not, and then we'll just, if it is in place, we'll just skip it, okay. Then the case 2 becomes, if nums of 5 is in place, we'll just skip it, or just don't swap it, okay. And the third case is that, what if all elements are placed at their right indexes and the array ends? What if all of the elements are placed at their right indexes, as we desired? Then what we will be doing is just return the element which is one greater than the array size, okay. So for example, we have an array of, let's say this is 0 index, 1, 2 and 3, right? So 1 will be placed here because we want an element to be placed at one less than the that element. And then this is 2, and this is 3, and this is 4. Let us say this is the case. Then what we will be returning is, we will be returning a number plus 1 to the array size. What is the array size? This is 4, and we'll be returning a number plus 1 greater to it, which is 5. Okay, so we'll be returning 5. So we'll be returning 5, which is return nums.length plus 1. Sorry, plus 1, okay. We'll be returning this. So these were the three cases that we had to keep in mind. The first one is, if the maximum number is greater than array size, or the current element, if it is greater than array size, then we'll just return that index. And the case 2 is, if the number is already in place or has already been swapped, we'll just skip it. And the third case is that, if every element is in its place, we'll just return an element, sorry, we'll just return a number which is one greater than the array size, okay. So we'll just delete this, and we'll write out the code. So the first thing is to track or keep a record of the length, nums.length, okay. And then we'll use a for loop, int I is equal to 0, I is less than n, and I plus plus. And in this, we'll be checking, or we'll be putting a while loop, because we are using a while loop because it will end uh, after a condition does not satisfy, okay. There is no need to use if again and again. We'll just use while loop and just write out the conditions. It will just run, and it will, this is for swapping, okay. We will not write if condition blocks 3 times for 3 conditions, and that is uh, which is used for swapping. We'll just write out a while loop which has all the 3 conditions, and it will just swap the elements, okay. Now the first condition is that nums of I is less than or equal to n. Okay, while the number is less than the array size, we'll run it, and nums of I is not equal to nums of I minus 1. We'll be seeing uh, whether the number is already in its place or not. And the other thing is, we have elements of negative nature. Okay, we have negative numbers also, so we have to skip them. And to skip them, we'll write nums of I should be greater than 0. Okay, so these are the three conditions that needs to be followed for swapping. And for swapping, we'll create a variable temp which will keep the record of nums or of the current element, and then the current element will get swapped with temp minus 1. What is temp again? Temp is nums. So the current element the current element's position will get swapped by a number which is at one less which is at an index one less than the current element. Okay, and then we will put nums of temp minus 1 is equal to temp, and then we'll just, this is for uh, putting element of nums of I minus 1 into nums of I position, and this is for putting nums of I in nums of I minus 1 position. Okay, okay, so this is how swapping will work. And then we'll just stop the for loop. Okay, and then we'll run another loop which is for int I is equal to 0. See, after we have swapped and after we have swapped, we'll be again scanning the array and check whether everything is in place or not. So that's why we'll be running another loop which is I is less than n and I plus plus, sorry, and I plus plus. Okay, if, what was the condition? If nums of I, which is the current element, if it is not in place, which we have desired, that is, the number should be in a place where it is plus 1 to that value. Okay, if that is not obeyed, then we'll just return the number of the index. We'll just return the index, which is I plus 1. Okay, and then after, even if sorry, after we have checked and we have observed that every element is in its place, now what we'll be doing, we'll be returning a number which is plus 1 to the array size. Okay, return nums dot length plus 1. Okay, so this is the code of cyclic sorting approach. Okay, so we'll just run it. Okay, so placing of the condition was wrong. Okay, I guess it's because of the short circuit nature. When one condition does not uh, uh, obey, then just cancels out. So okay, it's because of that short circuit. Okay. and we have our code running at 1 meters millisecond, 1 millisecond. And we have also used a memory of 1. We haven't created any memory, we have just manipulated, or we have just changed the same array we have been given. Okay, so the space is O of 1. And uh, see, you might think this makes it O of n square, but you will be wrong. Why? Because this is, we are traversing the array in a linear fashion, and we will be swapping the array. Okay, we will be swapping the elements in a linear fashion. So in total we'll just be doing this in of n time. Okay, and this loop also runs for O of n. So O of n, sorry, n plus n is 2n, and in big O we'll just write it as O of n. So ultimately the time complexity is O of n, and the space complexity is O of 1.